Let us learn something about the heating effect of electric current. Nowadays, in everybody's home, there are geysers which we use to get the hot water. But before the geysers, there were some heating instrument which we used to call as the water heater. There was simply one coil of some metal through which the electric current used to pass, and this electric current will generate the heat, so that whenever you immerse this coil into the water, a bucket of water, the water gets heated. Okay, let us see the lab setup of this experiment. Okay, now suppose I have a beaker. Okay, now we will form a circuit where we have a battery, then we have a key, then we have an ammeter. Okay, and this we have up to this level, the water is there. So these two ends are immersed here, and here you have the coil, metallic coil you have here. Okay, you can easily measure the voltage across it. This is a simple circuit diagram for this. Water is there. This coil is immersed into the water. Let us find out the temperature of the water. Let us dip one thermometer in this. And here is one stirrer. Mind well, I can even show you some slides of this setup. Those actually realistic photos will not be useful for your exam. Why? Because whenever you have to explain the heating effect of electric current, you have to draw the circuit diagram. And this is the circuit diagram you have to draw. You don't have to draw any realistic figures of any experiment or so. Okay, so now what I have done, I have created a simple circuit. I have not completely described the circuit here. Some things you have to do, that is giving the plus and minus sign, key, ammeter, and so on, show the flow of current, etc. Okay, now what will happen? Now whenever I close the key, the electric current will start flowing through this circuit. Okay, it will complete the circuit. What will happen? Whenever I close the key, the current will start flowing through this circuit. Okay, and whenever the current starts flowing, means what happens? The free electron starts moving, and whenever the free electrons will have some obstacle, or it will collide with each other, with atoms, with ions, or some resistance is there, at that point, whenever they got some obstructions, a part of kinetic energy is converted into the heat energy. So this coil or this metallic coil will get heated. Now how much will it heat, how much faster will it heat, will depend on the metal of this conductor or this coil. For instance, here I have used nichrome wire. Here I have used nichrome coil. The nichrome coil will heat faster. This metal will heat faster. Okay, and when this nichrome coil will heat, what will happen? This heat will heat up the water around it. Simple. And we have the stirrer. We will pass the electric current for say 10 minutes. First of all, before starting the key, what we will do? We will record the temperature. Okay, we'll close the key and we'll start stirring these things. For 10 minutes the electric current will pass. After 10 minutes, we'll close the key. We will check the temperature of the water. You will find that the temperature of water is increased. After few minutes, again we'll pass some current for next few minutes. Again we'll record the temperature, and the temperature of the water now has increased more. So it is confirmed that the heat is being generated. Now, what will happen if I increase the battery, increase the power of the battery? What will happen? So I increase the current. So within the same period of time, this temperature will be higher. The water will heat up faster. Okay. So let us learn about the Joule's law. Now let us consider that the V is the potential difference is applied between two terminals of a conductor of a resistance R. So by Ohm's law, what will be current? If V is equal to potential difference, R is equal to resistance, then by Ohm's law, I is equal to V upon R. We got this first equation, or we already know this equation. Now if the current I is passing through the conductor for time t, then what will be the charge? The charge Q. So t is the time. So charge Q will be IT. Okay. If the electric current is passing through the conductor for time t, then the electric charge will be equal to Q is equal to IT. Now the potential difference is the work done during the flow of electron or during the flow of charge. So now the work done during the flow of charge will be given by work is equal to potential difference into Q. Charge. And mind well that this work done will be converted into heat. Now in this case, we know what is Q is IT. Let us say this is a second equation we have. If you substitute the work done, V is equal to IR and Q is equal to IT. So simply you can write down I square RT. So work done will be I square RT, or you can simply write down VIT. Okay, this is just a simple substitution of formula. So this work done is going to be converted into heat energy, and work done is always calculated in joules. This is the unit of work done. But whenever the heat energy is there, we generally calculate that in the calories. So we have to convert these joules into calories, and the formula for that is 4.18 joules is equal to 1 calorie. And so the heat production in the conductor will be equal to, now H is the heat, equal to I square RT upon 4.18 calories. You can go in either way, or you can just by heart this formula. Okay, there will be sums based on this. So heat will be equal to I square RT upon 4.18 calories. So now how you will state the Joule's law? The amount of heat H generated in a conductor of resistance R when a current I flows through it for the t seconds or the t amount of time will be directly proportional to the square of the current and directly proportional to the resistance and directly proportional to the time for which the current is flowing. So now how will you state the Joule's law? The Joule's law states that the amount of heat generated H in a conductor of resistance R when the current I flows through it for the t amount of time is first directly proportional to square of the current, second directly proportional to resistance, and third directly proportional to time. Mind well, you have to write this in words. I have shown the directly proportional sign and the notations, but you have to write that in words. Okay. This is the Joule's law. By using this Ohm's law, we can further simplify the formula in terms of V, R and I. Okay. How we can write that? This H, we know that I square RT, the first formula is this, I square RT upon 4.18 calories. Secondly, you can write down that V square into T upon 4.18 into R. What I have done? Simply instead of I square, I have substituted V upon R. So there will be V square upon R square comes here, 1 R will get cancelled and V square T upon 4.18 R will be there. And the third is VIT upon 4.18. All the units are calories. So this is the Joule's law. Whenever you have to state the Joule's law or define the Joule's law, you have to write all these equations, you have to write the formulas and then states that the statements. Mind well, these statements I have written in a notation form, but you have to write all this into the sentence form. So now let us go ahead and see some of the applications of heating effect of electric current. Now let us see the applications of heating effect in an electric circuit. Just remember one thing, that in any electrical circuit, the resistances are there, so the heating will be there. Okay, whenever the circuit board is very small, just like on your computer chips or in your precise or in your mobile, you know that your mobile also gets heated because the circuits are there, power source is there, and definitely the resistance is there. So for the long duration of the time, if it is active, it will get heated, right? But so this heating cannot be avoided. You can minimize it, but you cannot avoid. But we can make use of this heating in our general appliances. Like we can have electric geysers, electric heaters, toasters, electric iron, electric kettle, even the bulbs. Nowadays we are using the LCDs or CFL bulbs. But in the olden days we used to use the filament bulb. The tungsten filament is used in the bulb. So applications of heating are innumerous. So let us see few applications of heating effect of an electric current. The first application is electric bulb. Mind well, this is not electric bulb which we use nowadays. Generally we use the LEDs or the CFL bulbs. This is the old style electric bulb where there is a globe, glass globe is there. It is sealed here and one filament is there. Okay, this is a glass globe, hollow. This will be called as filament, and inside this gases are filled. Why gases are filled? These gases are chemically inactive gases like nitrogen or argon. I'll explain you why this is used. First of all, let us concentrate on the filament. Now, which filament is suitable as a bulb filament was a very critical decision. Edison did nearly 2000 experiments. That means he tested 2000 elements or 2000 substances to check which will withstand for more time and longer duration, which is best for this filament. And after 2000 experiment, he found that the tungsten filament is used as a bulb filament. Okay, why? Because tungsten has very high melting point, 3380 degrees centigrade, very high melting point. That is, at this high temperature the tungsten will melt. Whenever any metal is heated, generally first it becomes red hot and then it will become white hot. When it becomes white hot, it emits the light. Strong light it will emit, which we say that the bulb is glow. What happens? A strong electric current passes through this filament. Now you might have seen small bulbs also, okay, where the bulbs which are operated by the batteries, cells, 12 volts, 1.5 volt, 3 volts, and the bulb is used in a house are generally works on the electricity, main electricity. Okay, when a strong current passes through this, it gets heated. First it gets red hot, then it gets white hot, and it emits the strong light. Okay, as its melting point is very high, at that temperature it will not melt, it will keep on producing the light. Okay, but then why this bulb is filled with the neon and argon gas? Because any metal which when heated, if it comes into the contact of oxygen, it will get oxidized, and it is not advisable for us to let this filament get oxidized. Why? Because then the life of the bulb will be very small. Okay, so what we do, we use the gases like nitrogen and argon, which are chemically inactive gases, and fill this bulb with those gases. So the oxygen contact is breaked from this filament. We do not let the oxygen comes in contact with the filament. So the oxidation of the filament is avoided, and hence we get the light from the bulb. Now again we can make some experiment that if we put a rheostat here, or if we control the current, if we increase and decrease the current or the voltage, what will happen? The bulb will be dimmer or very harsh. That can be done. So this is about the electric bulb, where the electric current heating effect of the electric current is used. Let us see one more application of this heating effect. Okay, the second application we will see is the electric iron. Electric iron which we use to press our clothes, shirt, pant, trousers, our clothes. Okay, in this also heating effect of electric current is used. How? First of all, the part which comes in the contact of our clothes is of a metal block. Okay, a thick metal block is there which directly comes into, which is polished and directly comes in the contact with our clothes. In this metal block there is one mica block or mica sheet, thick mica sheet is embedded. This is a metal block. And this is a mica sheet. Now in this mica sheet, a coil is embedded in this mica sheet. It will look something like this. Generally the shape of electric iron is something like this. Now this is the shape of the mica sheet, thick mica sheet, in which the coil is embedded. If by any chance, if you have any wasted electric iron or which is not working, you can just open it and see that in the thick mica sheet a metallic coil is embedded, pressed inside. Okay, whenever the current passes through this coil, now this coil is of a metal of very high resistance. You know that the resistance, heat generated is directly proportional to the resistance. Now whenever this resistance is there and electric current is passing, the heat is generated. Of course it depends on the strength of the electric current or the voltage, but whenever this heat is generated, this heat is passed to metallic block. Now why mica? Okay, why don't we directly embed this coil on this metal block? Very simple. Metal is a good conductor of electricity. If this coil comes in contact with the metal block, what will happen? When you touch that metal block to check the temperature of an iron, you will get shock. The mica is a substance. You might have seen mica, okay, which is a shiny silver substance. And you get the layers of the mica which is blocked to form a big block of any size. Now this mica, the property of this mica is it is a good conductor of heat but bad conductor of electricity. So whenever this coil is embedded in the mica sheet and mica sheet comes in contact with the metal block, what will happen? The heat is transformed from the mica or the coil to mica, mica to iron block or whatever block, metal block. But electricity will not leak. Okay? So you will not feel any shock here. So in this way, nowadays we have different controlled irons, that means different buttons are there, rheostats are there, and you can control the temperature of an iron. But the basic principle of this is the same. Here we are again making use of heating effect of an electric current. Let us see the third application of heating effect. Now we will see very important application or the use of this property, and that is fuse, electrical fuse. What is this fuse is? You might have seen in your home in a circuit breaker. Sometimes it happens that electricity breaks somewhere and we open our main junction box and we take out some ceramic part and then we change the wire inside. That wire generally gets burnt out. We change the wire. You might have seen sometimes. That is called as the fuse. That wire is called as the fuse wire. This wire is generally made from the alloy of lead and tin. This fuse wire is made of lead and tin. What is the property of this fuse wire? This fuse wire has got low melting point. Okay. Now what will happen, I'll tell you. Suppose fuse is not there at all and your home appliances or the home electric circuit is working directly and something goes wrong. Okay. Something goes wrong, some electric defect is there and temperature is going on increasing. Temperature goes on increasing. What will happen? It will blast or it will ruin all the electric appliances in that circuit. Maybe your AC, your TV, your fridge, your fans, lights, everything will get affected if something goes wrong. If the voltage is or the current is suddenly increased, if the current or voltage is suddenly jerked, is high, what will happen? A lot of amount of heat is generated and all your appliances will go. To avoid this, we use the fuse wire. That means, suppose this is your home electrical circuit. I am not showing any appliances here. I'll just show you if fuse is, this fuse is connected in series. And what is there in that fuse? In this fuse, that is one ceramic part is there. In that, a thin wire is there. This is the fuse wire. Actually, this fuse wire, through this fuse wire, the electricity flows. Okay? And this fuse wire alloy is selected in a way that at a particular voltage or particular current, the amount of heat generated will melt this fuse wire. And once this fuse wire is melted, this circuit is broken. And once the circuit is broken, what will happen? Everything will go off and will not get damaged. Generally this fuse, suppose from outside, suppose this is your home, and from outside, if that your main currents comes here, before going to any of the applications or any of the appliances, the fuse wire is immediately inserted here. Immediately in series, immediately fuse wire is inserted and then it goes to any appliances of your home. So what will happen? if something goes wrong on your main meter boxes, if current rises suddenly, if the voltage rises suddenly, what will happen? First of all, the temperature of the electricity is first passing through the fuse. The temperature of the fuse will suddenly increase, which will enough to melt that fuse wire, and there will be no electricity after this point. And so the whole of your remaining circuit will be safeguarded. This is the main application of heating effect of the electric current. Let us see one more application. Now, before closing the fuse section, let me tell you that fuse wires are generally embedded in the porcelain or ceramic parts, which is actually called as the fuse, and a wire that is called as the fuse wire. This is very highly insulative material. Ceramic or porcelain is a very highly insulative material. So whenever you want to change the fuse, you will not get shock. Okay. For domestic purpose, this fuse wire generally comes in the rating of 1 ampere, 1.5 ampere, 3 amperes, 5 amperes, up to 10 amperes. It depends where you want to use. So this is about the fuse wire. Now in the industry, for the soldering, for the cutting, for the drilling, everywhere this heating effect of the electric current is used. Now in the today's advanced world, there is one more use of this heating effect. Now inside the human body, nowadays doctor used to insert the probes, which is called as the laparoscopic operations. Okay, in the laparoscopic operations, the probes are inserted inside, which has the platinum or gold probe on it, and when that is heated and inside your body, some tissues, if they want to burn some tissues, if they want to cut some tissues, that technology is used. In that, generally gold or platinum is used because they do not get oxidized and they are very clean, so they can be safely inserted inside the human body. So in the surgery also, in the nowadays surgery also, laparoscopic surgery also, this heating effect of an electric current is used. Now let us solve an example which involves the calculating heat of some electric current, resistance, voltage is given, and we want to calculate the heats in calorie. Let us do one example. Find the heat generated in calories if a current of 0.2 amperes, let us write down, current, that is I, is 0.2 amperes, is passed through a coil of resistance 418 ohms. Resistance 418 ohms for 1 minute. So T is 1 minute, that is 60 seconds. Mind well, this must be an SI system. So if they give in minute or hours, you have to convert them into the seconds. Now we know the formula. H, heat generated, is equal to I square RT upon 4.18 calories. Okay. So now this is a very simple arithmetics, just substitution of formula. I 0.2 R 418 T is 60 seconds divided by 418. Simple arithmetic calculations, do it fast. Pause your video and find the answer, how much heat is generated here. Do it. The answer is 240 calories. 240 calories heat is generated in this case. Okay, let us now move ahead to next topic.